Welcome to AIMS University, Malaysia. Chain isomerism. In this session, we will look into the details about chain isomerism, its definition, properties, examples and applications. Definition of chain isomers. Chain isomers have the same molecular formula but differ in the order in which the carbon atoms are bonded to each other. Let's see the properties of chain isomers. Chain isomers are caused by different arrangement of carbon skeleton. They have the similar chemical properties but have different physical properties. The more the branching, the lower the boiling point. Now let's see the example for chain isomers. Let's take C4H10. It is chemically called as butane. It has two structural isomers. One is a straight chain molecule where all the carbon atoms are in a single row. The other is a branched molecule where the three carbon atoms are in a row and one carbon atom sticks out of the main chain. Let me explain you in detail. Now you can see there are two structures. The structure on the left hand side is a butane and on the right hand side is 2-methylpropane. These both have the same elemental composition. That means the carbon and hydrogen count are same for both the structures. But the left structure is a chain isomer and the right structure is a branched isomer. Let's see the differences between the chain isomers. Chain isomers have the similar chemical properties because they have the same functional group. But chain isomers differ in physical properties like density and boiling point. Boiling point of straight chain isomers is always higher than the branched ones. Let's see what is the reason. The reason is branching decreases the effectiveness of intermolecular forces and less energy is required to separate the molecules. So always branched isomers have lower boiling points compared to straight chain isomers. The structure on the left hand side is butane and the structure on the right hand side is 2-methylpropane. Straight chains always have more boiling point compared to the branched chain. Butane is an example for straight chain where it has a boiling point of -5 degrees centigrade. 2-methylpropane is an example for branched chain isomer where it has the boiling point of -11.7 degrees centigrade. It shows that the greater the branching, the lower the boiling point. Coming to the industrial application of chain isomerization of alkanes. Chain isomerization is used in petrochemical industry to produce branched alkanes with higher octane number from linear alkanes for fuel more suitable for petrol engines. The proportion of isomers as well as the hydrocarbon chain length in crude oil doesn't match specific market demands. Straight chain alkanes are heated with suitable catalyst to break up the chains and more branched alkanes as well as lower alkanes are formed on recombination of fragments. For a given carbon number of alkane, the more branched the alkane, the higher the octane number. The higher the octane number of fuel or molecule, the less tendency it has to cause autoignition resulting in knocking or picking in the car engine. Now you can see there are two examples given here. The left example is heptane, the right example is 2,2,4-trimethylpentane. Heptane is a chain isomer. It is linear with a formula C7H16. It has octane number of 0. 2,2,4-trimethylpentane is highly branched chain isomer with a formula C8H18. It is usually called as isooctane and it has octane number 100. One possible isomerization reaction of pentane is shown here. It has the formula C5H12. It can exist in two forms, that is pentane, a linear form, and 2-methylbutane is a branched form. Each form can change into other form depending on the reaction conditions. But if you place pentane, it has octane number 62. When you convert the pentane to 2-methylbutane, it has the octane number 93. So here we can use the reaction conditions to improve the octane number from 62 to 93. So these are all various examples of chain isomers. Thank you.